In this video, we're going to rewrite the given equation in slope-intercept form. We are then going to state the slope and the y-intercept, and then graph the equation. So let's start. This equation is not in slope-intercept form. Please remember that slope-intercept form has y equals first. So if we identify that the y is right here, I need to cancel out the 3x. I'll do that with the additive inverse. 3x plus a negative 3x equals 0. 0 plus 4y is 4y. So we did the inverse and used the identity property to do 0 plus 4y is 4y. But the equality property of addition says that whatever we do on one side, we have to do to the other. So if I add a negative 3x on the lower left, I have to add a negative 3x on the right. Now, when I show that negative 8 plus a negative 3x, I want this to be more in slope-intercept form, so I'm going to put the negative 3x first, plus negative 8. But because we're a little bit higher level, we don't write plus negative 8, we just write minus 8. Now the y is still not by itself, there's a 4 there. So this time, since the 4 is being multiplied, I'll do the multiplicative inverse, where the inverse of multiplying by 4 is to divide by 4. Please remember that 4 divided by 4 is 1. That again activates the identity property, and 1 times y is y. I'll keep my equal signs going straight down. And if I divide by 4 on the left, I must divide by 4 on the right. Now, same equality property, now just with division. So I'll do the negative 3x minus 8 and divide it by 4. Please remember that the numerators can be separated. So I will separate the negative 3x divided by 4 and put it on the left from the minus 8 divided by 4 and put that on the right. But 8 divided by 4 is just 2. And the signs are different, negative or minus 2. When we separate this, please remember that normally when you're adding fractions, you would add the numerators, denominator stays the same. We're just separating the numerators, your denominator stayed the same. 8 over 4 just became 2. Now that I've done this, I have a slope. We are in slope-intercept form, y equals mx. So the slope, or the m, is a negative 3/4. Now, for the slope to be negative, that means, and remember, fractions are division, the signs were different. So I can write a negative 3 over a positive 4. The signs are different, where negative 3 is the rise and 4 is the run. Or it can be the other way, where the 3 is positive and the 4 is negative. A negative 3 divided by 4 is a negative 3/4. And a positive 3 divided by a negative 4 is also a negative 3/4. Our y-intercept is a number being added, plus negative 2 would make it a 2. Negative 2. When you go to graph this, your y-intercept is the point on the y-axis. Since it is negative 2, I will go down to negative 2 and put my y-intercept. I'll then graph using my slopes, my rise and run. I'll do the first fraction. A rise of negative 3 means go down 1, 2, 3. A run of positive 4. Positive runs go to the right, 1, 2, 3, 4. Again, a rise of negative 3 would bring me off the graph, so I'm done. I go back to my y-intercept and I'll do the second fraction. Positive 3 means a rise of positive 3. Negative 4 means a run left of 4. 1, 2, 3, 4. Then I go again. A rise of 3 gives me 1, 2, 3. But my run of negative 4 would bring me off the graph, so I'm done. Once I have my points, we connect them. We draw a straight line using a straight edge. And then we go back to the original equation, 3x plus 4y equals negative 8, and you write your original equation. And that is how you can write your equation into slope-intercept form and then graph using slope-intercept form. Please make sure you have this work right here if it's in slope-intercept form, and you have all the work if it's not.